Bismillahirrahmanirrahim. Today I wanted to talk about similar polygons. Polygons, as you recall, are just closed geometric figures that have segments as their sides. So what you see before you here is a pentagon. So now let's say if I were to make a copy of this pentagon. Say I'm going to select this and then I'm going to paste it. So now I have like a duplicate copy over here, okay? And let's see if I'm going to do one more time. I'm going to got another copy over here. But this time, see, I'm going to enlarge this a little bit clearly. It's going to be bigger than the first one. See, now these two here are the same. In other words, they are congruent. And we express that symbolically like that. When two polygons are congruent, you can just take one and just put it right on top of each other and they would fit perfectly. Now these two over here, on the other hand, clearly they're not congruent, right? But they're not exactly unrelated either. In fact, they are similar. So these are similar polygons. Now, what makes two polygons similar? Although it's very intuitive to appreciate that polygons similar, how do you describe that mathematically? How do you describe that geometrically or algebraically that two polygons are similar? In other words, what makes these two polygons similar and not congruent? Well, you might say, well, it's because the sizes are not the same lengths. But it's a little bit more than that, because I could take the same size lengths and put them in different order and make a different pentagon. There are two defining features, in fact, of similar polygons. The first one is all corresponding angles are congruent. The first defining feature of similar polygons is that all corresponding angles are congruent. But that's not the end of it. The second important feature of similar polygons is that all corresponding sides are what? Are what you think? Proportional. So those are the two defining features of similar polygons. Now, what do we mean? First, now all corresponding angles being congruent means this angle has to be congruent to this angle, and this angle has to be congruent to this angle over here, and this angle over here has to be congruent to this angle over here, and this angle over here has to be congruent to that angle over there, and finally this angle over here has to be congruent to this angle over here, all corresponding in the particular order. So all corresponding angles have to be congruent. Now, what about the second condition? All corresponding sides have to be proportional. In other words, if this was, let's say, 5, and I doubled it from here to here to make it to 10, and if this was 4, I would have to double this over here to make it at 8. And if this was a 6, I would have to double that to make it into 12. And if this was a 3, I have to double that into making it into a 6. And if this was 4 again, I have to double that into making it into 8. In other words, all the sides are proportional. Whatever you do to one side, you have to do the same thing to all sides to keep the figures similar. So, the definition of similar polygons has two parts. One is that all the corresponding angles have to be congruent. The second important defining features of similar polygons, or the second important aspect of the definition of similar polygons, is that all corresponding sides are proportional. So now let's do this exercise. Let's call this side 2. Let's call this side 4. Let's call this side 5. This one looks like 3. I'm just making this up, all right? So forgive me if I make mistakes over here. 6. Now, let's say I double the size of this polygon. So I made this 4 over here. So this 2 became a 4. Now, since I doubled it, every single side has to be similarly doubled. Okay, so this 4 will become an 8, this 5 here will become a 10, and this 3 will become a 6, and the 6 over here will become a 12, like this. That's what it means for the sides to be proportional. In other words, the ratio from here to here, that is 2 divided by 4, that ratio has to be maintained in every single one of them. That's just 4 over 8 over here. Right? And then similarly over here 5 and 10 over here, and then in 3 and 6, and finally in 6 and 12. And as you can see, the ratio is always the same. See, what we have to appreciate is that you can't change the side length without also changing the angle in that area. For example, if I take this pentagon over here and I take this point A and just try to move it towards B to make that side smaller, you'd also notice that this angle changes. So you can't change the side length without changing the angle length. So anytime you change the side length and you change the angle measure, and anytime you change the angle measure, in fact, you also change the length of the sides. So, and that is the reason why similar polygons have to have both corresponding angles being congruent and corresponding sides being proportional. Because if you change one, you affect the other. If you change the angle, you change the side length. If you change the side length, you change the angle. So for two polygons to be similar, both the side lengths have to be proportional and all the corresponding angles have to be congruent. Okay, let's do some questions. So I have two rectangles here. So it's given to us that these are rectangles and these measurements are as follows. And these are all right angles over here like this. The question here is, are these similar? Well, if these two are similar, then all the corresponding angles have to be congruent. But that's easy now because they're all right angles and they're all congruent. Well, how about the corresponding sides? Are they proportional? Well, if they are proportional, then the corresponding sides have to be in the same ratio. So 10 over 15 has to be equal to 14 over 21. Well, are they? We can simplify these fractions and you can say, oh, well, this is going to be 5 goes into both of them. That 2 times, 5 goes in there 3 times, so that is 2/3. And over here we can simplify this fraction. Okay, 7 goes in both of them 2 times and 7 goes in there 3 times, so that's 2/3. And as you can see, the corresponding sides are proportional, so therefore these are similar rectangles. Okay, let's do another one. Here we have another figure. We're simply asked to determine if they are similar or not. Well, if they are similar, all the corresponding angles have to be congruent and the sides have to be proportional. So let's do it. So you pick an angle. Let's pick this one over here. And okay, that one's 90 degrees. So this one is 90 degrees. That checks out. So I'm going to go counterclockwise here. I have to make sure I go in the same order in both figures. Okay, so then 90 degrees and then followed by 60 degrees. Okay, got that. And then followed by another 90 degrees. Got that. And then followed by another 120 degrees. Okay, got that. So that checks out. So all the corresponding angles are congruent. Now let's do the corresponding sides. Well, 10 over here and 5 over here. Let's do the ratios. 10 over 5. That has to equal to 18 over 9. Look, I'm picking the right corresponding sides. 6 over 3. And then finally 4 over 2. And all have to be the same. Now, if I had done the other way around, let's see if I had done 5 over 10, going this way first, like this over this. And that's okay too, as long as the ratio is the same between the two, right? You can simplify this. Okay, so 10 over 5, that's 5 goes into both of them, that's 2. So as you can see, all the sides are the same ratio. So this second figure is basically half the size of the first one. So therefore, these are two similar figures. Okay. Now here we are told that the figures are similar. So we are told that the polygons A, B, C, D, E, starting from here, is similar to this polygon over here, G, H, J, K, L. G, H, J, K, L. Now here we asked to solve for things that are unknown over here. Okay, so let's start out with the angles. That might be easier. So this angle here, angle E, corresponds to which angle over here in the second figure? Well, you're starting out with A, which is over here, and then you're going over here. So it's the second corner, right? So from here, you're going to the second corner. So that's H. So E corresponds to H. So E is going to be 92 degrees, just like that. Okay, so the next angle in question, okay, so we did this. How about F, angle F? Which one does that corresponds to? That corresponds to 120 degrees, doesn't it? So angle F is going to be 120 degrees over here. And then how about angle G over here? Well, angle G corresponds to angle E over here, which is given to be 40 degrees. So this is 40 degrees over here. So I think we got all the angles. Now let's talk about the sides. So now we have to find the side A over here. Now we know that these figures are similar, so all the sides have to be proportional. So we can set up a proportionality. So this side over here corresponds to this side over here. So I can say A over 2 equals, so that has to be proportional to some other sides. Well, I can't pick this side because over here is another unknown. Okay, so let's not pick those two sides. How about this side over here? Yes, I could do that because those two sides I know. So A over 2 has to be equal to 4.5 over 3 because all sides have to be proportional. All I do is I solve for A. So in this case, you can cross multiply or just multiply both sides by 2 like this. So A is going to be 3. So there we have it. So we got A. So now we have to solve for the next side. Let's solve for D over here. Let's set up a proportionality for that one. So we have D over, now D corresponds to this side over here. D over 3 equals to, now you can use any side now that you know about it, correct? You can use even these two sides that you figured out, right? So it's going to be 2 over 3, correct? So this over the A that we just found out. And as you can see, D is going to be equal to 2. That wasn't so bad. Okay, let's find out B. Let's set up a proportion with B. So you have B over, now the corresponding side to B is this one over here. So this one over 1.5. Now I have to go back over here. I'm going to pick this side, I think. I'm just going to pick 3. And the corresponding side to 3, we calculated that out already. That was 2. So there we have this. And then we multiply both sides by 1.5. So B is going to equal to 2.25. I shall leave C for you to do. Okay. So in summary, similar polygons are polygons that have corresponding angles, all corresponding angles that are congruent, and all corresponding sides are proportional. Inshallah, next time we shall build on these concepts. I think it's great fun. Until then, as-salatu wa-salamu ala rasulillah, walhamdulillahi rabbil alameen. Assalamu alaikum.